Hi and welcome back to R for BRFSS. I'm Jennifer, your instructor for this tutorial series. We are now in the third and final chapter of our three-part segment on logistic regression analysis. We just finished analyzing our data and now we're going to visualize it. And at the end of the last video, I said that now we're going to analyze, but we just analyzed, so now we're visualizing. All right, so let's hop right back on over to R. This is the table we produced at the end of the last video. It has our health variable, odds ratio, confidence intervals, adjusted odds ratio, and confidence intervals on the adjusted odds ratio. Now we want to plot our data. So we are going to use the ggplot command. The data frame, this table, we've called it table 1, so that's our data frame, is called table 1. Our aesthetics are we want to set the health variable on the x-axis, and we're going to start by looking at the odds ratio on the y-axis. We'll use a bar plot. Stat equals identity means to include the value of that variable and not try to plot a histogram, but include the value of the variable from the aesthetics argument. And position equals dodge means to don't stack the bars, but to put them side by side. So we are going to start by looking at this ggplot. And these are our results from our odds ratio. Let me go like this, and because I know my video is in the bottom corner, so there, that should look good. So these are all of our health variables on the bottom. R puts them in alphabetical order. And here you see these are our odd ratios. Here's, this is probably where 1 is, so 1 would be the reference, and these are the odds for having good or better health if you have positive health behaviors related to these health variables. So next we want to put in a line to see where our odds ratios compare to our reference value. So to add a line, we keep the same command, but we plus geom AB line. We want the slope equal to 0 because we just want a straight line, and we want the intercept to equal 1. So this will put a line at 1 where our reference value is. So now we have a line, but it's kind of thin and it's a little dark to see. So what we're going to do is change the color to red. So this is the same command, but I just included color equals red. And now we have a red line. It's still a little hard to see. So we're going to increase the size to 2. And that should give us a little better, we'll be able to see it a little bit better. So now we have a nice thick red line at our reference value of 1.0. So these health variables, you have an odds ratio of having good or better health depending on these health variables in comparison to the reference value at 1.0. We also calculated confidence intervals on our odds ratios. So we're going to add the geom error bar with our aesthetic, the y minimum being the odds ratio lower limit, and the y maximum being the odds ratio upper limit. If we just plot those as is, the error bars will overlap and look kind of weird. So we're going to change the width and put position equals dodge just to make that display a little bit easier to look at. All right, and now we have our odds ratios with the confidence limits in comparison to our reference value. Now I want to save this graph, so I'm going to press History, Add, and now I think that should have added it to my history, so now I'll be able to refer back to it later. I hope that worked. All right, so this is odds ratio. We want to do the same thing for adjusted odds ratio. So we're doing the ggplot command again, still working from table 1. Our aesthetics, we're setting the x-axis to health variable. the y-axis to adjusted odds ratio, our bar stat equals identity. Stat equals identity, so we want the bar to reach the value of our adjusted odds ratio. We don't want it to take the count or the frequency. We want it to report the value from our variables contained in our aesthetics. Position dodge, so that the bars are not stacked but they're next to each other. We're adding an AB line again at the intercept equals 1. So this is our reference value equals 1, slope equals 0. We're coloring it red and making it a little bit thicker at size 2. And adding our error bars where the y minimum is the adjusted odds ratio lower limit. The y maximum is the adjusted odds ratio upper limit. And we're just changing some display options on those error bars by specifying width and position dodge. And when we run that, this is our figure for our adjusted odds ratio in comparison to the reference and our error bars. So let me add that to the history. And now I think if I do page up, yep, now we can see odds ratio compared to adjusted odds ratio. That's great. But what I also wanted to do was compare the odds ratio and the adjusted odds ratio bar graphs on the same graph. So to do that, we have to change our table a little bit, because now we have separate columns for the confidence intervals compared for each of the odds ratio and adjusted odds ratio, and we don't have a way to specify really what our statistic is. So our statistic is the logistic regression analysis outcome, right? So what we want to end up doing is making a table with one column called health variable, one column called stat, which will contain these values for odds ratio and adjusted odds ratio, another column that we'll call type, that will say this type of statistic is odds ratio, or the type of this statistic is adjusted odds ratio, and then just put the confidence intervals for the lower limit and the upper limit just in 2 columns, and then we'll know what the confidence interval is for because we'll see it in the type. So maybe that doesn't make sense, but it will. So in order to do that, we are going to make a new table called OR, big OR table, and we're going to select just the variables that relate to the odds ratio. All right, and the reason why we have to do that is, again, I couldn't get the rename function to work, so we kind of have to manually change the names of our variables and add a new column. Okay, so we're selecting these variables, we're adding a column called type and populating it with OR for odds ratio. We're adding a column called stat and populating it with the contents of the odds ratio column. So we want the stat column to contain our values on the odds ratio. We're creating a column called LL for lower limit and filling it with the contents of the odds ratio lower limit column. We're creating a column called upper limit and filling it with the contents of the odds ratio upper limit column. All right, so I'm going to run all of these at once. Now let's take a look at OR table. And we have some duplicate columns, but you can see now we have our type column. So these are all odds ratios. The lower limit and the upper limit columns they're duplicates of these columns. So that looks good. And our statistic is this odds ratio column. These values went into this. Okay, so now we want to select the columns health variable, statistic, type, lower limit, and upper limit. And the reason why we're going to do that is because we'll do the same process with adjusted odds ratio, and then we'll stack the 2 tables on top of each other. So instead of having the 2 tables, displayed odds ratio and adjusted odds ratio side by side, we'll have them all in one column. And from that new table, we'll be able to make a bar chart with the adjusted odds ratio and odds ratios bars right next to each other. Okay, so let's select those variables for our OR table. Let's look at our OR table. And now we have what we're looking for, HV stat type LLUL. And we're doing the same thing for adjusted odds ratio. All right, filling the new column type with AOR, filling the stat column with the values in the adjusted odds ratio column, changing this adjusted odds ratio lower limit column name to lower limit, just LL, and the upper limit to UL, and then selecting the appropriate variables, HP stat type LLUL, which if you look here, these are the same variables as here, which will allow us to stack those two tables, or rather bind those rows. So I'm going to run all of it together. And let's look at AOR table. And now we have our table. Just like we did for odds ratio, we have it for adjusted odds ratio. Now we want to bind these two tables together, which we will do by, and we'll call this table 2. We'll call the rbind function, which is row binds, and we'll just bind OR table and AOR table. Now let's look at table 2, and we have everything together. All right, so great. Now we can plot this. Now we can plot our two types of odds ratios together on the same graph. And we are going to call this figure odds ratio, adjusted odds ratio. So we're setting this ggplot command to a function, to an object called figure OR AOR. Right, so our ggplot command, we're working from table 2. Our aesthetics on the x-axis is the health variable, on the y-axis is the stat. So the values of our statistic, right, whether odds ratio or adjusted odds ratio. We want it to fill the bars according to the type of statistic. So whether that's odds ratio or adjusted odds ratio. Geom bar, stat equals identity, position equals dodge. Again, we're adding this line, and we're adding our error bars. So let's go ahead and run that command. Let's look at that figure OR AOR, and let's see how it looks. All right, look at this. So now we have the blue bars are odds ratio, the pink bars are adjusted odds ratio. So we can see, yeah, your odds of having good or better health across these different health variables, whether that's just looking at the odds ratio for just that variable or the adjusted odds ratio for all of the variables contained in the model. All right, and then the last thing that we can do is we can add a title to this by calling the print function and then putting our object, this ggplot object, as our first argument, and then calling the title ggtitle. And you can call it whatever you want. I'm just going to call it odds ratio and adjusted odds ratio. So let's run that command. And now we have our title on our graph. And actually this red line is kind of hard to see. You could change the colors of the bars, or you could change the color of the line. But yeah, basically this is how you do it. So I want to save this to the history as well. Add, let's make sure the other ones are still there. Adjusted odds ratio, and the two of them together. So we've made 3 charts. The last thing I did was kind of just for my own entertainment. I basically, if you remember from the prevalence estimates tutorial, we made a bar graph comparing the weighted percentages across the different health variables. Well, I didn't want to go back in and rerun all that code for prevalence estimates. But what I did is I wrote some code to make a figure for the unweighted counts. So that's, it's not quite the prevalence estimates, and it's not quite as statistically rigorous, but it still gives us some idea into the distribution of these different health outcomes in comparison to self-reported health across our survey population, if not across the whole state of California. So I'll make this code available. Maybe I'll make it available because there's a limit about how much you can put in your description on YouTube. So I don't know if this code will fit. But it's not really important to our discussion about odds ratios and adjusted odds ratios. But I just, I wanted to see what this would look like. So I'm just going to run all the code together at once. And just kind of quickly go through it. So I set an object by counting each of the health variables against the self-reported health. All right, I did that for all of them. Then I bound the rows. I call that counts. I created a new column called HV for health variables containing the names of those health variables. I added that column to our counts table. I called that counts2. I subset the variables that I wanted to keep. Then I made a figure using ggplot, which I called figure counts. Then I printed that figure and I gave it the GG title of counts. All right, so it's basically the same process we went through before. I'm just going to run it all at once. And we get this. So let me save this to our history as well. Add to the history. So here, the reference for good health is in blue. The reference for the comparison of poor health is in pink. And our variables, the reference is outlined in blue, and the comparison is outlined in pink. So this just kind of gives you like a good visualization to confirm what we learned from the odds ratio and adjusted odds ratio table, is that, for example, for asthma, if people who have good health and don't have asthma, people who don't have asthma are more likely to report good health. There's a greater number of people. There's a greater number of people reporting good health who don't have cardiovascular disease. There's a greater number of people reporting good health who don't have diabetes. All right, so just looking at the counts, you can kind of see that this is just a visual comparison of our odds ratio table. So by looking at this and looking at this, you can kind of see that they're related, obviously. The thing though is the counts is unweighted, our odds ratio is weighted. So this is consistent with our survey design. So this is something you would want to publish. If you wanted to actually compare and publish this, I would recommend looking at the weighted frequencies that we made the similar table for in the prevalence estimate segment. But overall, so these are basically our main findings. This is our main data visualization. And in this R for BRFSS course, we've kind of been running with this hypothesis of California girls would have better health than California boys. But according to this analysis of odds ratio and adjusted odds ratio, sex has no effect on self-reported health. So men and women are equally as likely to report good or poor health, even controlling for all the other variables, all of the other factors we included in the model. So for this one, it's a wash. Neither boys nor girls win this one. All right, so that concludes this segment on logistic regression analysis. I'm going to close my R session. I don't need to save the workspace. Make sure I saved my code. That's good. Close that. Close out all my windows. It's fine. If you need a copy of the article, please message me and I'll send you my copy. All right, with that, so what we're going to be working on next is we'll do the same thing. I'll choose another article and we'll just work through it from start to finish. So yeah, thanks for joining me this time. I'll see you back here next time. Bye.